sorry. Okay, so we are going to discuss about how the join we can perform using MapReduce, right? So if we have so we have a data set 1 and we have data set 2. Okay, so I'll take example of customer and the sales data, right? Data sets 1, which is like think of as a customer data set. Right, generally the customer data comparatively lesser than the sales data, right? So this is the smaller data set. And what the other data set you have is one is order data set. So example, this is a data set 2. Orders or sales, whatever. So this generally will have the huge data set. So it will be large data set. Okay. So also if you have this scenario, the you want to join between two data set and one comparatively smaller which can fit into the memory, okay, and another is the huge which anyway will be we cannot actually fit into the memory, right? So if you have a scenario similar scenario, what the MapReduce framework does is it gives you option to load this data set in memory. Okay, there is a concept called distributed cache. Okay, so you can actually load your data into this distributed cache. Okay, so what it does is if you pass your data set to this distributed cache, and say you will actually pass this as your input, right? So this input is will be taken into the distributed cache, and this is the actual input you pass to the MapReduce program. Okay, and say this is the your input location. So based on number of blocks this has, okay, say example, if this data set has for consider block 1, for simplicity sake we'll take 3 blocks. You have 3 blocks. This data set is converted to 3 blocks. So what will happen? You will have 3 mappers running for your data set. Mapper 1 here, mapper 2, mapper 2 and mapper 3. Okay, mapper 3, right? So now say what will be the kind of linking key here when you want to build a relationship or join between these two data set. What is the key generally we make?
Customer ID might be.
Yeah, customer ID, right? So what you need to do in your mapper, you need to make uh, you need to make your data set in such a way that okay means you get actually is a one row is represents your one order detail, right? So you take that order detail and split your records based on the delimiter, and you take the customer id. Say example, I will take customer id, and then say order amount, and what say example based on what aggregates you are going to do. Okay, so if you are going to do aggregate based on customers, then you can take this as a key. See from your order details. So order detail might contain a number of values, but for joining with this customer data set, we definitely need a customer id. And for aggregation, or what type of aggregation you are going to do, based on that you need to take other columns. Say example, for I'll take two scenario. One scenario is I am going to create a aggregate order amount, or maybe simply sum of order amount. So anyway, I'm not going to do here. I'll come to this. There are two scenarios we can consider. One scenario is find total sale for each customer. This is one, and then find total sales for each um, customer. For example, store wise, based on store, each stores are location, or whatever uh, things you want to consider, you want to find. Say example, these two scenario. So take first scenario where you want to find out total sales for each customer. So what you do, so from a customer information, you need actually customer id and order amount. Okay, so this is your kind of value, you pick it from your order detail, the line which is coming as input. Now, so whether to you want to consider this customer or not, so basically you have to verify, right? So whether this customer is available in the customer data set, then only you have to out it as a output of mapper. So what we do here, you have to just say check if customer id equal to um, I will okay I will say map of, and map will have a key value place, right? So if we pass this customer id, okay, okay, so I'll write in Python syntax. Okay, if this is if this is applicable, okay, so then you write say context dot write of context dot write of your key is a cust id, comma the order amount as a value. So customer ID and order amount you will be sending as a output of your mapper. So when it comes to reducer, all customer ID will be grouped. So like the similar customer IDs will be grouped, and all the order amount will be your collection of your order amounts. Then you can do sum in the reducer function. This is how you do for this first scenario. Do you have any question on this? Okay, so before we are going, how do you make this map with the distributed cache? So in your in the MapReduce program, okay, as per my knowledge, this joining data set is joining of two data sets can be done using only Java program. In using Python, I don't know whether we can do it. Uh, I'm not sure. Just have distributed cache here. I think so. So this whatever the map, the joining data set which I'm discussing, this can be done using Java. Python, I am sure. I'm not sure whether we can done using a Python. At least I think it is not, but not sure. Okay, so if you go here, MapReduce program mapper.java. Till now we discussed about the map function. Okay, map method. There is one more method called public void. Okay, so if you go to this, we have a setup method. Okay, okay, so I have to explain you. Actually, there is a concept called inheritance in object-oriented programming. I don't know how many of you familiar with this. So basically, when you want to uh, inherit properties from the parent class, okay, so if you have a one class which contains a set of methods, right? If you want to make use of it, you can actually do the uh, extends that parent class. Okay, so in you have to say in object oriented terminology, we use inheritance, and you have to override that method to have different implementation if you want to have it, or if you want to use the same implementation, you can call that method here. Okay, so if so we are actually using the MapReduce framework mapper program, which contains four method. Okay, so setup, map, which we were actually working on this, and then there are other property like cleanup and run. Okay, and okay, this is the context. So these are the, if you ask somebody ask you what are the four methods available in mapper, the MapReduce a framework mapper, these are the four methods: setup, map, cleanup and run. So the run method will is the one which calls your the map method for each key value pair. And if we have any before this map method calls, the setup method will be called. The setup method and cleanup method will only one time calls for entire or mapper that particular mapper life cycle. Okay, say example, this mapper life cycle is, if you take any okay, so we'll come back. I'm just pouring more information. Please stop me if it is confusing or if you are not understanding. So what this mapper does, basically this mapper will be spawned for your with the input of one block. So unless you complete reading this content in this block, this mapper will be alive. So 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 it will start from say example, this block has 10 lines. It will take this block and read one by line, 1, 2, 3, 4, 5, like that. So first, it before starting the line one, so there will be a setup method will be called. So in the setup method, so basically all your initialization steps we need to do on this setup method. And if you want to clean up, if you want to do some cleanup activities, which you set it on the setup method, and you have to do in the cleanup. So this map method is will call for every 10 lines you have in the block one. Okay, that's why you get a um, um, so so how this is run. So this run method will run, and the run method is the one which calls your map method for each key value pair. Okay, so for this joining data set, so you have to overwrite your setup method and read your data from the distributed cache, right? The data, the small data set you passed here. So basically you need to inside your setup method, you have to read the file and put it into some collection object. Let's say in the span Java terminology is called hash table or hash map, okay, which will store the key value pairs. So you should store customer ID as key, and value you can have it with whatever values you want. So that's how we are actually doing the join between these two data set. Okay, so once you write the key value pairs customer as a key and value as amount, so the aggregation will be same as what we do on the normal reducer aggregate logic.
Okay. So this join condition can be multiple, even customer ID with the date.
So basically how many say example, so here read the, say example, read the customers dot txt, say example txt or csv, whatever format it has, and prepare the map. Okay, so which will have key value pair. A key equal to, right now I'm considering customer ID. Okay, prepare map which key as a customer ID, and then value as, you can keep whatever, say example I just put customer city, the customer name. So for all, you read the entire data set and you prepare this map, so you'll have multiple key values, multiple customer IDs. So based on that you do the join here. So if you have multiple columns, so you have to make a key like that, say example you want to join with the customer ID and also with the customer location, right? Then you prepare that the expected data from your customer data, and here also you will have a location column in your customer details. Then make your concatenation of customer ID and location, have it as a key. That's how you need to prepare that join key based on your requirement.
Okay. So finally, it will be one key for next step, right?
Each
If
map
it
is
is
going to search all customers. We have 100 customers. Yeah, so it has to do the all the data set. Yes, because the you have all the customers, 100 customers in distributed cache, which is on your it is on your map. So in both the in the three mappers, it will actually, because this is in memory, so this your the under say what, how many number of customers you have it, that is in map, right? So 100 mappers are how many, whatever the how much data which can put it like or sit on the memory, that much it can hold. Definitely there will be a performance in it, but no other go. Okay, so yeah, so that is will I no other go, and I have one more workaround, I'll tell you next actually. So this entire uh, um, concept or this kind of pattern of doing is called map side join. Okay. Okay, so here what we are doing it, so because here the one data set is in one data set in uh, one data set in distributed cache, and other data set is coming as a mapper, right? So you make your join condition in mapper. So that's why it is called as a map side join. Okay. So one more thing is in the uh, so so once you write your data, means you once you map your data, um, it is going to have your data set which consists of whatever you decided which need to be taken for the output of your mapper. So the join, one thing is with the smaller data set, this applicable only when one data set is smaller, other data is smaller which can fit into your memory. Okay. So other data set is can be larger. It can be whatever size, because it's going to generate anyway the different mappers for number of blocks you have. You have any question on this?
No, buddy, we are good.
Okay, so I'll just show you one diagram. Okay, so this, so one more thing. Okay, I just missed it. So here you will have uh, so map side John, you will have only the map task. Actually, reduce task will not be there. Okay, so so you have to write another program to do um, the reduce method. Okay, so this if you want to put it in a different way, so you run your MapReduce program. Sorry, so your data set, that small data set, uh, you specify in job configuration. It goes to the distributed cache, hash table files. Okay, in the distributed cache. In from distributed cache, you prepare using the prepare the hash map or whatever. You do the join, then you write your output. Okay, from the distributed cache, a small data set is coming, and for big data set, each record will be coming to your mapper, which we discussed there. Yeah. So as Nanda you asked, so this data set, entire data set reading, which from memory is will happen in all the mappers. Okay. So say example, you come to another scenario. Okay. So where okay, so we'll take it. So if this say it has a different file. Okay, so if this data set, take, okay, so this is if you have a data set which is a larger. think of. I check which is the. Okay, say this is the larger data set one, which can. So if you have two data set larger, right? So this the first data, either one of the data set cannot fit into the memory, so we cannot do the MapReduce map side join. Now we have to go to the other way of doing a join is a reduce side join, where both data set cannot fit into the memory, right? So what we do here is, say again this data set is having some, I'll take two MapReduce, and this has, say this data set has two or many mappers. Okay, so based on blocks, this one B1, B2, and for data set one, you have block one here. Okay, and B2 here, B3. So how we can do join is, so we know like individual when you read for individual block, so you will now have any context to the other data, right? So, so because previously the scenario which we discussed, the map side join is one data source relatively smaller which can fit into the memory, so we were having it in the uh, distributed cache and converted into hash map, and we were doing the comparison, the rough joining. But in this case we cannot do that. So what we do is, you each anyway the mapper will get called for each blocks, both for data set 1 and 2. So here you can actually in when the key values pairs are coming for, right, so you can identify the file name of your uh, file name of your particular block it is reading. So say example, this is the uh, this is the uh, okay, so find out this, yeah, sales happened on city 1. Okay, this is the sales data for city 1, and just I'm just assuming it. Okay, and this is the sales data happened on city 2. Okay, so now when you read this block, so you should be in the MapReduce, at least when it is also applicable in Java only. So you can actually access your file name of your this respective block. So example, this is from the city one data set. We have what we are, this block is belongs to city one data set, and this block is belong to city one data set. That you can identify if there is a property to find out a file name of your this respective block. Similarly, you can find out okay, this is, this belongs to sales hyphen city1 dot txt. and this also similarly. And here you can understand, you can actually identify this belongs to sales of ct2.txt. Okay, once you identify this, now you need to prepare a key value pair, right? So this will get, the mapper will get input as each line from your this sales data set. Now you need to prepare a key value pair in a mapper to tag your file, right? To tag your file, saying that this is from the city one, and then uh, if you want to make what to say, the customer um, um, customers one from city one and customer, if the customers you want to do join between customer 1 and 2. Okay, so sorry, customer from city 1 and city 2, if the customer, same customer is available from city 1 as well as city 2, you need to tag your key, have the customer the data set as a tagging. So when you do the tagging, then that based on the tagging, you in the reducer side you have to refer and do the join. um, so when it comes to here from the reducer side, um, okay, I will say here the output of your map, output of mapper will be like, mapper will be, what is that? Okay, so I will tag it um, okay, say sc1, and I will put uh, customer id. Say I check, I want to find out sales per customer id. Okay, so if that customer id is available in both the data set only, I want to do the aggregate. Okay, so it's something like that. Then this will be my key, and the value will be like generally order amount or whatever, right? So this will be a key value pair here, and here also. Here it will be C2. Hmm. This will not come right. Okay. We have more. Okay, I will see. Not this. Not this as key. Um, uh, okay, key will be different. Not this. So basically, you have to make a key such a way that that's been grouped. Okay, so key, I think it should be like, say say customer customer, say based on customer name. Okay, and the value will be you have to do the combine, like key is customer name and value will be like customer ID and then we'll prepare the concatenation and we'll pack customer ID and then the which tables represent. So sales city 1 and then order amount. Okay, so if this disconnect actually join back with the same link, we'll have one more like 10 minutes of session then. But these examples I will uh, do tomorrow, but we'll just discuss the concept and we'll find out today. Okay. Okay, so this will be your key and value. Okay, so here same customer name